Hello everyone, and welcome to this technical tutorial session on CloudStation. I'm Pierre Chapognat from the support team, and I'll be taking you through the features of the software. CloudStation is the new proprietary software from YellowScan. It's actually made for YellowScan LiDAR users and allows them to transform raw data format collected from their scanners to usable point cloud files in just a few clicks. CloudStation is currently compatible with the entire YellowScan product line except early Mapper 1 scanners. So let's get to it. I've prepared for this demo two datasets, one from the VX product line and one from the Surveyor. You can actually open one of the datasets. You just have to select the APX file, and straight away this will display the segmented flight lines. The process is fairly simple and fast. The display is divided in various areas. You have the main display here, which is actually a 3D display. You can manipulate the 3D display by simply right-clicking to pan. Left-clicking is to zoom on the point cloud, and the middle mouse clicking is to rotate around a point of interest. The upper toolbar here gives access to main settings from the program. You'll be able to see if the software has some updates directly. You can switch this on or off. You'll be able to check the license offline. If you go in the field, for example, you'll have to check the license off in order to be able to process without an internet connection. So when you go in the field for some surveys, do not forget to actually switch that one off, and this will give you 30 days of offline mode. The LiDAR tab gives you the possibilities to enter ball site data for each of the units you're actually using. So for instance, Surveyor units gives you 3 ball site entry. Ultra gives you 32 entries. You can actually create new LiDAR units if you have additional ones and enter their corresponding ball sites. In case you have another dataset to process, you can enter a new dataset. Here I'll process the Surveyor dataset as well, and this will generate a new tab with this other dataset that I want to process in parallel. So let's get back to the first dataset. The panels are quite rich in details. You have 2 main panels, an extraction panel that you can collapse or expand, and a display panel that you can also collapse. The extraction panel is divided into 3 sections: the project section, flight line section, and process section. Project section is the main one. This will give you details on the name of the files that you will generate from this. The projection system, this will allow you to select different projection. So if I'm not happy with the default one, which is the UTM zone of the flight area, I can still go and fetch other projection system. So for instance, here would prefer to project the dataset in Lambert. So I just need to click on it, or I can set it as my favorite and click apply, and now my EPSG code will change to 2154. In terms of post-process solution, if you're directly coming from the field, you probably don't have one, so this will be empty. You will have no PP solution. If you've already combined your static base station and run a post-back project and corrected your trajectory, you'll probably have a smooth best estimate trajectory solution, and this one will automatically pick it up from the root directory of your LiDAR files. In terms of Z reference, two options. Either you've defined a different autometric height, for instance in postback, and you want to apply it at the CloudStation level, so you will need to click on postback elevation define. Else, if you're in ellipsoid mode, you can just select ellipsoid. The LiDAR section, this will allow you to choose your LiDAR unit that you've defined in the settings, and therefore the software will apply the ball sights value that are entered under this serial number. The angle range, this is a fairly intuitive way of changing your scan angle. Default are minus 50 to 50 for most of the units. You can change those values depending on what you were scanning and how you were scanning it. If you were scanning things laterally, you might need to change the scan angles differently depending on what you want to see and how you were flying your object of interest. So for now, I'll just leave it to 50. You can also maybe just, enter values instead of looking at just that little tweaking round circle. Flight line section, this is probably the main one. This gives you what the software suggested as flight line. So the suggestion will depend on the minimum length that you've entered here, and this will be an optimal value automatically detected by the software, but you can change that depending on your flight configuration. It will automatically detect changes in heading and changes in speed. So the suggestion by the software is the optimal one, but you can always, if you're not happy with the suggestion, you can always change by simply editing the flight line itself. And when you're on the edit mode, this will give you the possibilities in a fairly simple way and intuitive way to change the start and end time of your segment and end your flight line. So if I want to push this further, I can, but I was fairly happy with what I had before, so I'll just leave it there. You still need to validate the flight line selection by clicking OK. If you are happy with the suggested flight line, you can simply process the extraction of point cloud. You can do it two ways, either by processing, and this will, if you have that ticked on, export LAS and trajectory, this will actually generate a LAS file and a trajectory file when you click here. If you just want to have it displayed just as a first check, you need to unclick this, and this will just generate point cloud on the fly without really generating LAS files. So this option is actually faster to process. So if I just want to have a quick look at the point cloud, I can just generate on the fly point cloud. So I just need to wait a little bit for the process to be finished. And this gives me a progress bar here and a progress bar at the top. So here my point cloud has been generated, and now I can use the display panel. The display panel is also fairly intuitive. You can shortcut views by just clicking on orientation and top view. You can toggle on off the trajectory or toggle on off the point cloud. You can also increase the point cloud or each point size, and you can colorize the point cloud by different attribute values. Here I see that I probably have some noise in the dataset here, for instance, that changes the coloring. So I'll simply change the coloring manually and adapt the coloring myself. And now I have a gradient which is more representative of the environment. There are different attributes that you can color the flight line, well, the point cloud from. Elevation is one. Echoes, so this would be the echo number. So echo 1 would be here displayed in white, echo 2 in brown. As you can see, there's like echo 2 coming out from the second echo of the electric line. This is echo 1 in white and echo 2 in brown. And then you have other echoes, because this is a mini Vox system that can record up to 5 echo. You'll have green and more echoes in the vegetation represented. Another coloring would be laser number. This has no real sense in a mini Vox system, as it is a single beam laser. It would have more sense on a Velodyne. You can color by flight lines. This would be useful to detect if there's mismatches. You can color it by intensity. So this would take the intensity recorded by the scanner and display it as a grayscale. So this gives you almost like an image of the environment. Scan angle, if you want, this would probably make more sense if we display the scan angle on a single flight line with positive and negative scan angles on either side. And time, if you want to look at time for the entire flight. The last section of the display panel is the picking mode. At the moment, I'm on what they call mouse-free mode. I can change that into picking mode, flight edit mode. So this would mean that I can simply left click on the trajectory, and this gives me the possibilities to generate a funny segment of my trajectory. So this is not something I would validate, but just to look how simple the selection would be, I can just decide on an extra flight line segment and say OK, and this would add a flight line number 5 that would still need to be processed if I wanted to extract the data, but I actually don't really want that, so I'll just throw it away. An extra mode would be the measurement mode. So once I'm on this measurement mode, I can do several things. I can click on a first point. This will give me some attribute data of the first point, including position, time, echo number, and attributes from the last file. And if I click on the second point from the trajectory, for example, this will display the distance. So this would be the slant range distance, and if I want a summary of planimetric distance, I would look at the plane distance or delta time distance. If I want to look at distance from one flight passes to another, I can. I simply need to click on the two segments of the trajectory, and this will give me the delta plane and delta time as well. So I can quickly jump on this second data set. I'll also select a different projection. I need to select the serial number of this scanner as well. And because I'm happy with the flight line selection, I can simply generate the last files. So while this one is running, I can still continue on the other one in parallel and continue my investigation. Maybe what I can do is, when I'm happy with a point of view, I can simply extract a screenshot just to display the view that I'm getting. So for instance, I would say I want to extract as a PNG this view, and maybe I'll try to see another pretty view from this angle along the electric power line. Maybe I can choose the background color. So here, to enhance the point cloud color, I would just simply click dark, and the trajectory color, so I'll keep it dark, and I can export that as a view too. Once I can now have a look at my views that I just extracted. So view 1 or view 2. During the extraction of my surveyor dataset, this is the result. Again, there's probably a little bit of coloring adjustment to run, and I can do this by simply dragging this elevation cursor a little bit in a better way, and this improves the gradient of the display. So if I want to zoom on an object, I can simply click on it and rotate around that object selected to see the surroundings. This one I have generated with the LAS. So if I want to see the folder where the LAS were exported, I can simply open the directory, and this will automatically open where my LAS files have been generated. So I have my 6 flight lines here, plus my trajectory file, which is a text file. So that's it for this tutorial. I hope you will find it useful to actually take control of the software, and I'm sure you'll find it so intuitive, you'll find this video as useful as a waterproof tea bag. But anyway, we'll definitely get back to you with additional features to make your life simpler when processing point cloud data coming from YellowScan scanners. And thanks for watching.